Alrighty. Happy Monday. We made it. Sorry I missed you Wednesday. I'm most of the way through the cold. I'm on Dayquil right now, which is making me really loopy. So I'm going to be more all over the place than usual. So just holler at me if I get lost. We'll bring it back in on topic. So we got most of the way through functions here. We didn't get a chance to finish them up last week. So we got a couple more pieces to look at with our functions. Function arguments. The default parameter values are really cool. I don't think we got to that one. Uh, Arguments list, that's not, it's cool. We're not going to do anything with it. So just know it exists. And then functions as objects are really weird. We didn't do that one yet. That's also a fun one here. Um, so let me start up a new project here, and I have the new IntelliJ finally. I think I finally got that downloaded and installed. Let's see how well it works for us here. Uh, let's call this one week 7 functions, and we'll make our welcome script. No, I don't want the free trial. Thank you. Could make a file for me. Not make a file. There it goes. Okay. So one is slower than the other one. That's quite an upgrade. So when we look at functions here, we did something like define print happy Monday. Oh my goodness, this is too much inline completion. No, inline completion settings. I don't want all that. Enable, no, disable that. Print happiness? No, I don't want that. Hello, or we'll do happy Monday. And it just prints happy Monday. Right, and then maybe we have another function that defines print reminder, and this one is going to say print, did you remember to do Zybo here? Okay. Now, this print reminder can take an argument here of another function. So we'll say, I don't know, print happy day here, and then we're going to call that function that was passed here. Total nonsense here. It's very weird. We're not going to do this, but you might see it occasionally, so it's good to know that it exists. So if we call print reminder and we want to give it print happy Monday, not the function call, but the actual name here. So if you use the parentheses, it will call the function. If you just use the name of it, it passes the name of the function in. It passes the function in. When we get to print reminder, it takes that function we were passed and then adds the parentheses to it here and then calls the function. Looks completely ridiculous, I know, but it works. And that way you can take your print reminder and you can give it different things. Instead of print happy Monday, we'll define print I'm sick and sad. And we'll print Dayquil Eric is weird. Right? So instead of that one, we could print our reminder with sick and sad, again without parentheses, because we're passing the name of the function here, and then it will be used within this where we're calling it here. And now we get a different greeting, happy day, to our print reminder. This can be useful, but at this level, it's not. It's just more confusing than we need it to be. So eventually, you'll see this. We'll do this sort of stuff here. It's going to be way down the road. But if you see these weird things happening, functions are technically objects. So if we were to say, hey, I wanted to print I'm sick and sad without the parentheses here, right? It says, hey, it's a function, print I'm sick and sad at, pretty sure this is a memory address. I should probably look that up one of these days. But when we ran this file, we said Python here, run this file, and it got to a function definition, it loaded that function in memory, and you reference it by name. So when you call the function, it says, hey, go run the code that lives here in memory at this location. And that's why we can also pass it as a value to another function, because functions are also objects. Really weird. It's okay. And their example, I think they print with a head. You can print different heads on a body here. excuse me. Yeah, so you can have the monkey face or the regular face here, but the body's all the same. It's very exciting. Um, this fun byte code that gets generated and executed is what's actually stored. Python's really neat. Does lots of cool stuff here, but not too important one way or the other there. All right, we did our named parameters, right? Where we said, hey, we didn't get to a named parameter yet. All right, so let's do, we'll have a, oops, goodness, define print day here, given a day, or no, print date here, given a year, a month, and a day. Let's go the other way around. Let's do day, month, and year. We'll pretend we're European, right? Day, month, year format, and it just prints out. Now, I prefer the ISO format, which is year dash day, or dash month, dash day, month, not Monday. Maybe I do need that autocomplete here. So this format is computer sortable, which is really nice. Like it alpha sorts very easily for you. Uh, and it's the ISO standard. So instead of this month, day, year, weird American nonsense where we go for like the middle size and then the small size and the big size, it's big, medium, small. And then you could even add the time after this, which are smaller units. I think this format's really nice. You could add in the hours and the minutes and the seconds and milliseconds and that sort of stuff. So it's definitely the better format. But using this function now, if I wanted to print the date, print, let's print date here, print date. If you wanted to say, hey, it's today, so 6/10/2025, that's nice. But most of the time when I run this here, it's probably going to be 2025. Right? Wouldn't it be nice to say, hey, let's default this to 2025? So I can say, hey, if you don't tell me what the year is, I'll just assume it's 2025. There we go. So I can get the same output here with the default value. How about for the month? Maybe we assume that's October, unless you tell me otherwise, because we're running it today. Excuse me. I can still pass it a month. If I pass it a month, I get the month I passed. If I don't give it a month, I get just the day. Right, I can pass it just a day here. So it lets your function be more flexible if there are things that make sense as default arguments. Okay, one of the functions we write, did it ask for a number between a certain range? Do we validate that? Does that ring any bells? No. We wanted to get number within range. And we said, hey, how about you give me a lower bound and an upper bound? Right? And we would go and get that input here. So we need an int of an input. So our number is an int of an input, of a number between the lower bound and the upper bound, lower bound and the upper bound. And then we can say while by, now lots of different ways here. I like the not here. So not lower bound less than or equal to number less than or equal to the upper bound here. Again, lots of different ways to go about it here, but this is valid. So if it's not valid, right, we're just inverting here. If it's not good, ask them again. So eventually we'll get something here and I can return the number. Right? Other ways we could write that, we could say, um, while the number is less than the lower bound or the number is greater than the upper bound, right? Either one of those, they do the exact same thing, right? If it's too low or too high, or if it's not good, right? Both do the same thing. It's just a style preference here. Whichever you like is perfectly fine. We'll go get a number. But wouldn't it be nice? We probably have the lower bound be set to 1 most of the time, right? So it'd be nice if I could say, hey, lower bound is 1. But now Python's mad at me here. Sorry. It says non-default parameter follows default parameter. You can't have a default parameter before a parameter that doesn't have a default. Because if we go try and use this function here, we want like get number within range, and I said, oh hey, I want the lower bound to be 1 and I want the upper bound to be 10, it doesn't know. So it's like, oh, do you want the lower bound to be 10? Right? It's expecting two numbers here, right? 10 and 20 or something. Here's a lower bound, here's an upper bound. So you can't just give it the one value because it doesn't know which one to match. So you have to flip the order around here so we can say, hey, here's the upper bound, and then the lower bound defaults to 1. So if I give it just one number, then, hey, my upper bound could be 10, lower bound is 1. Or if I want to change the lower bound, I can say, hey, let's make that 2 or something, whatever we wanted it to be. Because they get matched in order. It says, okay, the first thing matches the first thing, the next thing matches the next thing, right? With print day, maybe we even default this one to 6, right? So we print day. If I have two things, it matches the first one to the first one, the second one to the second one, the third one to the third one, right? But I can't change the year. I can't say, hey, the year is something else, right? Because, or, 2026, it's going to think that's the month because they go in order, right? We just match things in order. So it gets to be tricky when you have lots of default parameters. The way we can work around this here is using keyword arguments. So I can say, hey, I don't want the month. I want year to be equal to 2026 here. So this is a keyword argument saying, find this parameter, find this argument, and assign it this value. And I know it's not in order here. So you can go out of order if you use the keyword arguments here. And it gets to be really weird with these functions because you can do keyword arguments for ones that you don't even have defaults. You can have like a find print, what do they have, like a triangle, rectangle, right? Rectangle with a length and a width. And for row in length, I guess, I don't know, range length. We're going to print width times a star character, something like that. So sure, we could print a rectangle. We could say, hey, I want to print rectangle, and I want width to be equal to 5 and length to be equal to 10. We can go out of order if you use the keyword arguments. Right? Usually it would have to be the first thing was the first thing, the second thing was the second thing, right? So if we just say print rectangle, if I give it 10 and 5, IntelliJ, or I'm sorry, PyCharm is generating this length colon, right? Some people had saw that. It's just telling you, hey, this is the length argument. This is the width argument here. So if you don't name them, they go in order. If you do name them, you can go in any order you want here. So if you have lots of defaults, you can skip some if you're doing the named arguments. And it says, okay, this matches the first thing. It's a positional, right? First matches the first, second matches the second, what position it's in. So by default, we get positional arguments. But if you want, you can use named ones, keyword arguments here. You can have upper bounds and lower bounds and years and all sorts of fun dates like that. Excuse me, multiple outputs. Yeah, we did that one, right? Yeah, we did, where it packs and unpacks, right? It automatically makes a tuple. I think we did that one for multiple outputs. Let's see, I think that was all of them then. Oh, the namespace, space, and scope. So this gets to be really weird here. So if we have a variable outside of the function, like at the top here, my favorite number or something is 42. You can use that anywhere inside the file, right? Because it's defined up here, right? So I can say, hey, if we wanted to also print your favorite number is, and then do the formatted string, favorite number, right? That works out just fine. And we get my favorite number because it exists outside. So the scope of this is at the entire file. If we declare something inside a function or inside a loop or inside an if block, right, the scope was where it was declared, right, inside of that. So being able to find out which variable you're using, they go in order. Excuse me. So it uses these namespaces. So they have this global's namespace tracks everything that exists at the file level, the global level, right? Global variables, things that we declare exist in globals. So if we go and print globals, you can see the fun stuff inside of it here. Print globals for this one here. Give number within range, sure, 5. We see name and main and doc and none and packages. And so this is actually a dictionary, right? The key of name is associated with main. The key of doc is associated with none. The key of package is associated with none. Loader, something here, sure. Spec, annotations, built-ins. It's a bunch of stuff here. Here was the file itself. So the name of the file, the full path to the file. Here, the favorite number variable. Here, the print date function, right? This is how we can pass the name of a function. It exists in globals. It's been defined. When Python read this file, it adds stuff to this globals dictionary because now it exists at this global level here. So print date is, here's the function at this memory address, right? Here's the print rectangle function. It's a function of the memory address. Here's the get date. These sorts of, here's all your functions here at whatever memory address they exist at. So you can see all of those values here within globals, right? So that's different than when you would create local variables. So when we try and use something, right, in Python, it's going to resolve these from different scopes, which is lots of fun here. So we have our local scope, right? It's whatever is existing in the function. We have the global scope, anything we've defined inside the file, and we have the built-in scope, any of our Python stuff, any of the Python libraries, right? Int, string, list, range, any of those other ones here. So it's going to try and grab them from wherever they exist here, and it's going to look through and find it where it is. Um, so having multiple values here, it's fine. You have local variables and you have global variables. Perfectly fine. You can have the same name within, it just gets a little weird, right? So if I have a new variable for favorite number equals 20, it's going to tell me, hey, it shadows favorite number from the outer scope. Because there's one at the global scope and I'm trying to create one at a local scope, it's actually going to make a second variable. So it won't touch, it's not going to change the value of the global variable. It's going to make a new one inside of this function that's a local scoped variable here that I can go and play with. So if you don't want that to happen, you have to use a keyword. You say global favorite number here. So this is saying, hey, please go grab that global variable favorite number, and now I can mess with the global variable favorite number here. Generally, these are frowned upon, right? Because this just gets really messy really quick. Like who's messing with what variable, these sorts of things here. So we try and stay away from global values, except for like constants. Like, hey, here, those all uppercase. Hey, here's a number that it represents something. I'm not going to change it ever. In general, using global variables is just kind of messy. Is all.
Yeah, the global tag right there that calls the
Yep.
set
Yep. So it's saying, hey, go grab the global favorite number and pull it into my local scope, essentially.
that before you could after that put the equals 20. It has to be
I think, yeah, it's got to be. So go grab it first, and then we can assign to it. Yep. So this,
seven. Could you use the same variable in a function and then have that variable defined elsewhere and it'll just ignore the function unless you call it and that variable wouldn't get used, if that makes sense?
yeah, so if you define something as a local variable, it only exists when that function's running, and then Python
Gotcha.
throws it away. Yep. Yeah, so we can make other ones. We can make favorite number equals 20, and then it's like, oh wait, is this fine? Favorite number is 20? It gets real messy here. So in general, this is just a bad habit. So we try and avoid these sorts of things here, just for the reason is that it's messy. Um, but you can do those. All right.
They're never useful to call a model.
To like keep it existing outside of that function. So you have no way to do that unless you either return the value and you assign it somewhere, or you go and set a global variable to that local value. Generally, the local ones are just I need it for some quick arithmetic, and then I'm going to throw it away. I don't need to keep these things around because things that are in globals will be stored in memory the entire time our program's running, which for us is not very long, right? Our project runs, maybe a minute, depending on how bored you are. So it's not going to store a lot of things in memory. That's okay. But some processes, some programs run constantly, right? It's just something that's running on a server somewhere and it's, waiting for input and scanning for things. And so the more junk you pack into global, the more memory it's holding on to, and that equals bad performance in general, right? We want to be efficient. That's more the sciencey side of things we'll get to eventually, and you get into, the pure science of computer science. We look at how performant we can make our programs. For now, like everything we've done is pretty fast. It's not really going to matter. Our computers can handle it here. We're not doing billions of anything. When you get into actual data science stuff and you start crunching these really large data sets, yes, it matters if we can be fast or slow and how much memory we're holding on to and what we're doing and all those things. So we'll learn to make things more efficient as we go. For now, we're kind of spoiled and we just want to get the job done. I want to learn how to logically solve a problem step by step by step so I can make a stupid computer do it, uh, sort of at this level. Okay, so here's our global one. Keyword default parameters, we did those. The arbitrary argument list is really weird here. You can pass in with the star sign. I don't know why. A essentially list of values, but it doesn't have to look like a list. So it will let you pass in as many things as you want here, and it will essentially turn them into a list for you. So it's just like a shortcut. So we could say, hey, I want a list of toppings, and you could pass an actual list. But in this case, this gives us a shortcut to say, you just keep on giving me strings, and I'm going to turn it into a list for you behind the scenes, right? Oh, I'm sorry, a tuple, not a list, right? It's immutable at that point. So it's just a shortcut here, right? Again, like when we looked at functions, we haven't actually been able to do anything new. They didn't give us something like when we got to loops, now we can finally do something new, right? I didn't have a way to validate and make sure someone gave me valid input. I can ask them 10 times, but if they were stupid and gave me the wrong input 10 times, I'd still end up with the bad input. So loops was something new, right? Functions just let us put names to things and let us organize our code and help us solve problems more easily because we can do that functional decomposition. I can take a big problem and break it down into smaller and smaller and smaller and smaller steps because it's easy to solve small problems and it's harder to solve big problems. So with this argument list, it's just a shortcut, right? We could do the exact same thing, it's just a little shortcut for us here. And you can also have quards with 2 stars, which are keyword arguments or like a dictionary, right? Hey, this one is sauce is mustard, veggies tomato, veggies lettuce. Sure. And you can name your arguments, kind of like a dictionary, right? You get the key and the value, sort of, right? It's naming them. So an arbitrary list of keyword arguments. So you can do silly stuff like that. I think that's pretty good for functions, actually. I think that was it. We were going to move on to strings next, right? Which is good. I think we've got some time. Yeah, we can get into strings. We got time before lab. Um, and then don't forget your Zybooks for functions was due today. So we posted the chapter 7 Zybook ones for strings. Yep, chapter 6 was today, so chapter 7. I think I set one of these up as a file upload because I wasn't paying enough attention. My apologies. Um, so if it asks you to upload a file, just give me whatever here. It doesn't really matter. This is no submission. There we go. Just remember to change it every time. Excuse me. All right. How are we doing on our Zybooks? Really good, right? Okay. Halfway there for the labs that are due tonight. We're getting there. That's okay. Um, I'm sorry? All right. It's a good sign. Good sign. Um, yeah, didn't quite get there with the other ones, but that's, again, it's not the end of the world. They're your points if you want them. As we move on to strings, this one definitely has like more labs. There's not a whole lot in the strings chapter, which is nice. So we can finish it up today. And then on Wednesday, we'll talk about the project solution and then the next project, which will use functions and strings. It'll be really fun. All right, so we start up a new chapter for strings here. Let me save this. Here's functions. And then new project for week 7 strings. Welcome script. Oh, I wanted a virtual environment. Yeah. Oh, okay. Yeah, it's gonna make one for me. New window. No, every time it's gonna tell me I can get a free trial. Really? That's fun. I can get some coffee while that loads. I made my pop this morning. You guys want any? No. Okay. That's very excited. I'm sorry. I have cups in the CIS building in my office. Um, yeah, we could try. I should bring cups. You're right. I'm a poor host. My apologies. So we've talked a lot about strings already, but there's a couple interesting things here. So string slicing is something I'd mentioned before and forgot we didn't cover. So taking a slice is more than one index. Right? Before we said, hey, here's my alphabet is A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S. Yes, I have to say it out loud while I'm typing it for some reason. Like Literally, I can't make my mouth not move. It's the weirdest thing here. We could print out here alphabet at index 4, right? And then alphabet at index, shoot, what is this one? 20? No, 17. An alphabet at index, uh, I missed D. Oh my goodness. Is it 9? 10? And then alphabet at index 2. Hopefully that's Eric. Let's see. Oh, I was really close. ER. All right, just the J. I was off by one. You guys are impressed, right? That I can do my letters and my index. So this is one index at a time. Right, very exciting. If you want to get more than one index at a time, it's called slicing. You say, what index do I want to start at, and what index do I want to end at? Not inclusive. So, like when you range, it's not inclusive. When you slice, it's not inclusive. Okay, so I can say, hey, I want to print alphabet of from 0 to 3, not including 3. So indexes 0, 1, and 2. I'll get ABC, right? This way, ABC. I could say, hey, I want to print my alphabet index of, let's get everyone's favorite, the elemental P, QRS, elemental P. So that is, what is that, 11? Elemental P for like 5 more letters, so that's like 16, I think. Let's try that. Elemental P, which is the weirdest thing when we say it so fast in the alphabet song, and our poor children think that's one long letter. And they're like, no, those are separate letters. And like, why do you say it like one letter? Like, I don't know, we're dumb. Uh, I have never understood the alphabet song. So start index, end index. Now the fun thing is some of these are optional. So if you want to take, hey, remember we just looked at like optional parameters? We're going to assume the start is 0. We're going to assume the end is the end, the last index. So if you don't give it a start and you don't give it an end, you get from the start to the end. Right? I get the whole alphabet, right? Or I could say, hey, I just want from the start, give me the first 3 letters, right? 0, 1, and 2. Right? Or I could print, I want the last couple letters, alphabet, I wanted from 21 to the end, right? WXYZ. Oh, V, oh, 22. I was so close. WXYZ, right? They're optional. The other weird thing you can do is you can give it negative numbers, which, if you think about it, kind of makes sense here. So if I want from 22 to the second to last value, I can go -1, which counts in 1. I'm sorry, this direction for you guys, in 1, right? So this will give me everything but the Z, right? I can print, hey, I want the alphabet from, I don't know, let's go from 5 to -10. Right? It'll start at index 5 and go up to 10 from the end. Now, there is no 0, -0, right? If you want the last thing, you just don't give it a value, right? All you math types, there's no -0, right? That's a true statement. Okay, I'm not going to make some math prof mad at me. Pretty sure that's not a thing. Um, so you can count backwards, essentially, with negatives, which is really fun. The other thing you can do, remember when we did ranging and we talked about you could do the stride, the count by? You can do the same thing when you slice. If you want every other letter of the alphabet here, I want from the start to the finish, colon, counting by 2. That's the stride. I like to call it count by. Count by 2s. We'll get Ace Gik Moxoe. Sure, every other letter of the alphabet, right? If you want to say the odd ones, right? Every other letter will start at index 1, going counting by 2 to the end. Sure, we can get the other ones. So if you wanted to scramble up the alphabet pretty quickly, we can go scramble them up, right? Here now I've got every other letter, and then maybe I put them in order here, and we've messed up the alphabet. You guys ever see there's a really funny video of the alphabet sorted in alphabetical order by how you spell the letters? It was I found it really entertaining because I'm a giant nerd here. But it turns out the alphabet is just arbitrary. There's no reason we came up with A, B, C, D, E, F, like why we put them in that order is completely arbitrary. So if you wanted to alphabetically sort the alphabet, you could do that. All right, I gotta look that one up for you now. Can't play it though. I'm gonna have to do it later. We'll find it here on YouTube for you. Alphabetically sort the alphabet. Come on. Is this one it? I think this one, yeah, I think this is the one I watched here. Um, So it was fun. You can find all sorts of fun stuff on YouTube, right? Yeah, go down those rabbit holes. And then your search history gets even more fun, which is nice. So thankfully, I watch enough of the math videos. I get lots of fun math stuff. You guys like the stand-up math, the dice guy, right? He was cool. He's a nice guy. Um, so slicing makes a copy, right? So one of the things we looked at, right, we said, hey, if you want to pass a list to a function, you give them access to the list. They can add or remove from it. And I said, oh, if you want to pass a copy of the list, you can slice it with a colon. And it didn't mean anything because we hadn't got to slicing yet because chapters are out of order or some nonsense like that here. Not entirely sure. Um, so it gives you a copy. Now with strings, it doesn't really matter because you can't change a string anyway. It's essentially like a tuple, right? It's immutable. You can get things by index, but we can't change them. But with a list, then, right? If I had my, names was a list of Eric, Jasmine, Jeb, and Vivi, and I got a bunch of kids in the family. We could do that. So if I wanted to pass a copy of this here to my, I don't know, a define print values in uppercase. Why not? Here, given some list. Oops, nope. Goodness. Right, we could take for value in some list. Well, really, if we wanted to pretend to change them here, right, we could go do that here. So we could say for index in range, the length of some list, right? We can say some list at the index is equal to my some list at the index dot upper. Right, go and uppercase it, assign it back to the list here, right? And then we'll go print out, um, goodness, this value, some list at the index. That's tedious, but sure. Right, so if we go do this one here, we call print values in uppercase, we give it names. Now we're going to have changed the value of names, right? Because I gave it the list and we've assigned back here. So now my list is in all uppercase. Sorry. Oh my goodness. I told you it's all coming out now, which is really good. Uh, Better out than in, I always say. I think that's Shrek, actually. So if I wanted to not let you change my list, I want to give you a copy of the list, I can slice it. So you can slice lists just like you can slice strings, because strings really are like it's a collection. You can slice collections at this point here. So now I can do the thing, but it's done on a copy. So you can also slice lists, creates a copy. So depending on what you want to do with your function, if you want them to be able to change your list or not, we'll do the slicing. And you can do the same thing. Hey, I want from index 1 to 7. I want from index 1 to -2. I want it's going to default at index 0 to start. I want to count by twos. All those same things work the exact same way with lists as they do with string slicing, right? And so remember, we were never really passing the stride here because it was a default argument. Remember, we just wrote functions we came up with default arguments. It's going to the stride defaults to 1, which will give you every value. If you define it here, if you pass in the value, then it's like, oh, you want a different stride, right? That sort of thing. If you wanted to print, I forgot this one here, you can do the alphabet backwards, right? So we want, now this gets weird because I want from 25, I want to go down to including 0, down to -1. I want to stride by -1, right? Starting index, ending index, +1, or really -1, because we're going -1 in that direction, right? One beyond the end, and then counting by -1 here. We can get, oh, did I get it? Where'd it go? Did it not work? It didn't work. Really thought that works here. I'm a little, it's probably the cold meds. We'll blame it on that here. What? I'll come back to that later. That's my note to do later. It actually, so there's actually cool stuff in here. You can say to do, and then we'll highlight it here, and then there's like tools that will go through and find all your to dos and that sort of stuff here. Um, Lots of fun stuff here. Um, Excuse me, and then it pops out as a different color too, which is fun. Can't we? Why didn't that work? I'm really confused why that striding didn't work backwards. All right, hang on. Python stride string slice backwards. We'll Google it here. Oh, okay. I don't need to give it the options. That's probably why I got it confused here. So we just leave it as colon, colon. Now we get a backwards alphabet. Okay, so we don't have to give it a start and a finish. That's neat. What if we wanted to start and a finish though, like 20 and 5? All right, that works. So was it just the negative one? 25? No? Negative one? Oh, so you can't have negatives from the left. Is that right? Did I just leave out that one? Hmm. I think we can do negatives, can't we? Alphabet of -2 colon 5 colon. No, yeah, so negative values are unhappy. That's what my problem was here. All right, I got it.
So you give it negative values list nicknames.
So you can from the end, but it got confused when I tried -1 because it was like negative from the wrong side, right? Like -1 would have been one in from the end, but trying to go one in from the start, I think was confusing because one in is not the same as one past. So I think that's just negative ones are stick them, leave for negative at the end, counting in for the end here. That's probably safest. All right, so it's a string slicing, lots of fun stuff with slicing. More string formatting here. Know this exists and just go Google it. That's all you have to do, and you'll use it for the labs here. Uh, you can do all sorts of cool stuff with your output, like specify widths, right? Um, you can have sort of like padding characters if you wanted here. Um, so this is saying, hey, I'm going to go at least 16 characters for this one here, and then at least 8 characters. So it's just making your outputs look pretty here, and then how we align it, where the padding goes. So is the padding to the right or padding to the left? Right? These sorts of things here. Or do I want to center with my little caret symbol, which is a fun use of the caret symbol here. You could center your padding, essentially, right? So it tries to even out the number of spaces here. I could care less what your output looks like, honestly. And I think I've admitted that before. User experience is not my strong suit. I'm old and cranky. I'm not going to learn it now. I'm going to stick to my lane. Um, but most of the time, we don't even care what your text output looks like anyway, because most people don't run programs that run in the console. Right? Can you tell me the last time you ran a program that you got the little black box you typed in? Ever? No? I mean, they are very useful and interesting. You can write really cool scripts that do it, but at that point, you don't really care what your output looks like. If you want pretty output, you're going to like put it out in an Excel because there's Python can write files to Excel really easy, like Python to Excel. Like, come on, Copilot search. You know how much like energy this burns every time I search now because it uses AI. It's a little bit depressing, but hey, look, to Excel, done. That was it. Like, all right, I wrote it to Excel. It's like a one-liner now to dump stuff to Excel, which is crazy. You can do it in one line. But yeah, like if you want pretty output, put it to a program that has pretty output. It's kind of the moral of the story there. Sorry. So know the chapter exists. You'll do a lab on it here. My apologies. But crazy things you can do for paddings. Go for it. You can even fill specific characters as well. The floating point precision, we've done this one, I think, the 0.1f, 0.2f rounding to a certain number of decibels. That's pretty handy here. Make our output look a little bit nicer. Just go Google it, though. You don't need to memorize, hey, you have to do colon 0.2f. Right? It's not worth keeping in your head. All right. Oh, excuse me. String methods. This one's really fun. So you can replace string. Remember, strings are immutable, but we can go and do something. Skip. That was, wow. Why did that now just pop up? That's bizarre. I'm already all over the place. I don't need more pop-ups. I'm just going to get confused. So replacing values here can return a copy of a string that's been replaced. Right? It doesn't change the original. So it's always I need to replace something and then save that result every time. So I can go replace all I want, but it's not going to change anything. So I can take my alphabet here. We can call replace, and it says, "Oh, what do you want to replace? Let's replace A with how about B? Right? Here's the old character. Here's the new character. This gives me back a new string with alphabet replaced, right? It returns a string type. We can see here it's replaced. So if I want to change my alphabet, then I need to say alphabet equals the alphabet dot replace of that, right? Get the new value, assign it back on top of the old one, right? Because it made a new string, and now we need to save that new string. So that's the biggest thing people run into when we replace is we forget to save that result here because we're not actually changing the string. We're making a new string where they've been replaced, right? I can print out my alphabet. Excuse me. So instead of that one, let's do a silly thing here. Let's get like a phone number here. You remember when people have phone numbers with like words in them, like 1-800 call Sam? That's sad that was in my head, but sure, 1-800 call Sam. He's got all the freeway billboards. I blame the billboards here. For some reason, they work, right? You see it enough and it gets stuck in your head somehow here. All right. So if we wanted to replace the letters with the actual numbers here, right, we could go do that. So I want to replace. So I'm going to say my phone number equals my phone number dot replace. I'm going to replace what? What string? Well, A gets replaced, B gets replaced, C gets replaced. Right? So if there's a group here, I'm going to do this, for letter in group here, or letter in ABC, right? I'm going to take my phone number and I'm going to replace the letter with a 2. Right? For some reason, it's not a 1, right? Don't we start with 2? Isn't it? I'm not crazy, am I? I have to go look at my phone now. Yes, okay, good. 2. No one agreed with me. I got scared. Does no one do this anymore? No?
I'm not sure what.
You just Google what you want to call, right? You don't actually have to go by the letters. All right. Just don't make phone calls. I mean, that's better. My kid's orthodontist appointment got rescheduled. Like they have a whole text reminder. They're like, "Hey, we'll text you. Hey, we confirmed your appointment." And they're like, "Oh, we called you to reschedule." I'm like, "Why didn't you text me? Like, come on, be a normal person and like send me a text here." But all right. So for every letter, we'll replace that with a 2. Um, and now if we're doing this multiple times and the only thing that's different is ABC and the number, I'm glad you thought about it. We could do it, you know, not have a bunch of repeated code here. So we'll make a dictionary, right? So here's my letter to number dictionary, right? So my key of ABC has the associated value of 2. My key of DEF has the associated value of 3. My key of GHI has the associated value of 4, right? And on and on and on and on. We need to get all the way to get to SAM, right? Um, so the key of JKL is a 5, and then MNO is a 6, and PQRS. Wait, hang on. MNOPQRS. Right, that one's 4, isn't it? Yeah, I had to look at my phone. Yeah, that one's 4, and then WXYZ is a 4. What a terrible example. This shows how old I am. Man, I gotta remember to not do these. All right, and then TUV was an 8, and WXYZ. YZ was a 9, right? Yay. Okay, so now for every one of these, right, I can do the same replace with the key and the associated value, right? Oh, and actually, I should do these as strings here, right? Let me go and quote all these here. Oh, I can do the singles too. Oops. Oh, look at that. And let me highlight it and put quotes there. No, what did I do? If I highlight it and hit the quote mark, it does it. That's handy. Look at that. All right, so for I don't know what I want both. I need the letters and the values, right? We can get both things out if we want it here. So this is letters. Actually, let me leave this loop here. So for letters, comma, number in my letter to numbers dot uh, items, right? We'll get both out here. Remember, when we loop through a dictionary, we can get all the pairs out essentially here. For every one of those, then, for letter in letters, replace the letter with the number and then assign it back. So this is terribly inefficient because I've essentially made 26 new strings, possibly. Right? Every time this happens, here I'm going to replace and replace and replace and replace, making a new string and a new string and a new string. This is terrible. It'll be really slow, but 26 times still happens like that. If I did this like times a million, it'd be pretty slow. So eventually then I can say, I want to now take my phone number. Oh no, I did replace it here. So phone number, replace, we can print the phone number. We should have made this a function, right? Yes, that should be a function. Okay, so we'll define a convert phone number given a phone number, right? And then we'll do all of this thing here, and then we can return the phone number when we're done, right? Make sure we're giving it back. What's it upset with here? Phone number shadows from outer scope, really? Uh-oh. Oh, that's fine. That's this outer one here. So we get a phone number, we'll print it, we'll convert it, convert phone number, take the phone number, and then we'll print the phone number. Hopefully we get back the right. Oh no. Oh, we never changed it. I went through this whole thing. Strings are immutable, so phone number needs to equal. Phone number equals my convert phone number of the phone number. Right now I can change the string, right? Because I'm saving back a new version here. And now we get, hey, 1-800-call Sam is 2255726. Sure, why not? All right, so string functions, fun things we can do with replace. Oh, they're replacing, we can learn Spanish. Sure. So you can replace more than one letter at a time as well, right? This is the entire word you can replace. So you can replace any size string that you want. Anytime to find the match to replace that one. You can find values in strings at a given location from given indexes. You can find backwards. You can count how many times a string showed up here. All sorts of fun things here. And the in check is pretty helpful. That's why it popped up. There's a lab here, right? Is that a lab? It's like a try. All right. Comparing strings, right? Does one string equal another string, right? Case sensitive. You can see our strings greater than or less than other strings, which is super weird. But remember how strings, characters are essentially stored as Unicode values, the individual numbers here, right? So the capital A is the smallest of the alphabet letters because it's a 65. And then they just go up from there, 66, 67, right, and so on. And lowercase letters are smaller than uppercase letters. Yeah, so we can compare strings, great. Using the is operator is a little bit weird here because it's not the same location in memory, right? A string literal is not the place we just stored as some input value here, right? When we read it in Python, this gets loaded somewhere here. So we're comparing, is it equal to this? And it's not with the identity operator, but are the values the same? Yes. Other fun things you can do, and you'll do all these in the labs, very exciting. Is it alphanumeric? Is it a digit? Is it lowercase? Is it uppercase? Is it a space? Does it start with something? Does it end with something? Right? You can change your strings. You can make it capitalized. You can lowercase it, uppercase it. We've done. You can strip out trailing and leading white space. This is pretty helpful when we're dealing with input because maybe they had an extra space at the end and we don't want that extra space at the end. You can title case something here, the first letter of every word being capitalized, which is pretty fun. Yep,
You have to just put
just chain them
down.
together. Yeah, dot this, dot this, dot this, dot this, because every one of them returns another string that you can then go return another string, return another string. Uh, yep, very cool. And then the last bit with strings is splitting and joining. So this is pretty common. It's a nice handy shortcut for doing things in a faster manner. So the split takes a string and gives you a list of chunks here, and by default, it chunks on white space. So spaces, tabs, new lines will get chunked when you call split. So Martin Luther King Jr. becomes 4 strings, and all of those separators have been taken out. Now you can split on anything you want here. So if we had a CSV file, we could split on commas. Right? That sort of thing is pretty handy. Now, the problem with CSV files and commas is that sometimes you have text in CSV files that contain commas, and then that text has to be quoted. So you're not just splitting on commas, but you need to split on the quotes, but not all the fields are quoted. It's a whole bunch of nonsense. Right? CSV files are crazy. Have you worked with CSV files? They're fun here. Use the CSV library is the whole story here. You don't need to do anything by hand, but trying to chunk your own would be fun. So if we said like Chernesky, Eric, for a name here. And then we had, I don't know what, 3.9, I don't know, like, here's GPAs, right? And we had Chernesky, Jeb, and I don't know, 3.5, something like that, right? We got some commas in here. We want to save this as a CSV. Go. I hate their save menu. It's the word. Let's just put it on where'd my desktop go? Oh my goodness. It is not on my shortcut list here? Sure, put it in down. It's now home. Desktop. I really don't have a desktop option here. I'm so sad. Whatever. Put it in documents. Go for it. So here's test, and we'll make a comma separated CSV file here. Test.csv in documents. Test.csv. And if we open this up with a more options, open with code here, like a text editor, here we can see that one's quoted. And there's a comma inside. So you can't just split on commas. This whole story for CSV files, you can't split on commas, even though they're comma separated files here, because sometimes you have strings that should contain that. So you have to look for quotes first. Man, those cold meds are good. Good stuff. So splitting and joining, we can split, and then join is the opposite. You take a list here and you put it back together with a delimiter. So I can take a slash as my delimiter. I'm going to join a list of strings, and we'll put them together with that in between them. That's all. So lots of fun things we can do with split and join. Yeah, very exciting. All right. Excuse me. I think that's actually pretty good. Um, just a deeper dive into strings. You'll do all sorts of fun practice here, palindromes and Mad Libs, and removing non-alphanumeric characters, name formatting. You can do cool stuff with those. All right, we okay so far? We'll have lab this afternoon. We'll practice a bunch of these string things here. We did our functions lab already. That one's due later. If you didn't get it done yet, that's okay. We can finish that one up today as well. We'll do a strings lab, and we'll go from there. Looking forward, I can't believe we're like halfway through the class already, believe it or not, and this is early October. We have a midterm coming up. So on the 20th, I'll give you last year's midterm as review. We'll go through it. Actually, I'll give it to you the 15th so you can go and like practice the problems before I show you the answers. That's usually less worthwhile if I just show you how to do the solution rather than you trying it first, is all. More practice is good. And then the plan for the midterm is it's open book, open notes, open internet. I've never been asked by an employer to do something from memory because that's stupid. Why would they handicap their developers here? So I don't expect that from you. It'll be half short quiz style questions like true, false, maybe a fill in the blank, maybe a multiple choice. I don't usually like multiple choice because it's really obnoxious to write wrong answers and to come up with like 3 wrong answers. It just irritates me. Um, but you'll see last year's. So on 1022, I'll open it. The goal is it takes less than an hour. I aim for about an hour so that if people needed more time, they'd have the extra 15 minutes or so to do it here. So it's like 15 quiz style questions, true, false, short answer, fill in the blank, that sort of thing. That, hey, a minute each was the idea with 15 of those, and then 3 long answer questions that should take less than 15 minutes each. Like write some code to do something. Write some code to do something. Small amounts, right? It was not a project or anything. So that if I wanted to watch you take it in person, I could. I find that terribly dull, and it's open book, open notes. And anyway, it is not open neighbor. It's your own individual effort. It's honestly, it's made to be easy. If it's not easy, let's chat because something's not clicking right with Python. If my midterm is hard, right? I promise it's supposed to be easy here. So I'll open it on the 22nd. I don't plan to come because no one wants to sit around and watch me have them take a test, and it's not even timed. It's just due by the 27th when class starts. So take it anytime you want here. Go for it. Open it up, come back to it. I'm not going to put a timer on it where you have to finish it within a certain timeline because that's also obnoxious. And then, like, every so often, Canvas screws up or they're like, my internet died. And then you have to call me and panic. It's just not worth the headache. So start at any time after 12:30 on the 22nd. Turn it in by the 27th at 12:30, and we're good. That's the plan for the midterm. After that, we got a couple more chapters here. Now, when it comes to inheritance, we're just kind of scratching the surface. This is a topic we will deep dive on next semester if you continue on and you're stuck with me, unfortunately. That's a major topic of the next course, but we want to like introduce, here's the, you've seen it once, right? Well, like with a lot of math classes, you'll see something and you'll come back to it deeper later. Same idea with recursion. It's a whole project topic for next semester as well. We're going to talk about it briefly here and we'll look at the Python for Data Science chapter, which is really fun. These are pretty short sessions here. They shouldn't take the entire time. So the goal is you'll have time to work on the final project, right? At the end of every class, you'll have some extra time for it here as well. So files is a big topic here. We'll use files in the final project. But inheritance is pretty short. We've got Thanksgiving break. actually take a break. You shouldn't have anything that you need to work on. If you want to work ahead in the project, great, but we've got lots of time, right? Because we want to sign it till the 12th. Uh, we'll come back for some light stuff. And then on 12/8, the plan is we do nothing, right? Just work on your final project. Ideally, you finish it by the 8th. And then you don't have to worry about this class for final exams. And you just get to show up for presentations and run your code. You're like, hey, I finished it a week and a half ago, right? And you can actually study for your classes where you have to memorize stuff for exams because for some reason, some people think that's a good way to test if you know stuff, if you haven't memorized. That's fine. Uh, but we're about halfway, believe it or not. So we don't have that many more topics, right? We got lists and dictionaries, classes, exception and modules, files, a little bit of inheritance, a little bit of recursion, a little bit of Python for data science, and that's it. So we've gone through the first half or so of the class, um, believe it or not, and we're working towards the end here. All right. Awesome. Any other questions, thoughts, concerns? If not, we'll meet up at lab in a little bit. Post that in just a minute for you. We can go from there.